So here we are in the Microsoft Store, and they've made a new version of WinDbg, which is very nice. And I learned this because I was teaching this course, and I was complaining about WinDbg as being hard to use, and there was a student who is a Microsoft engineer who said, there's a new version that's better. And so there is. So I want to do this one here, Kernel Debugging. And so I got to find WinDbg Preview in the store. WinDbg Preview, there it is. You can only put it on Windows 10, as far as I can tell, but it's free, and it's really nice. I don't care about this. Signing as Microsoft. Okay, it's downloading something. Good. There we go. Okay, it's done. So all right, now we have to use BCD edit for local debugging. So I need to copy this stuff and run it in a command prompt. This is normal stuff you'd have to do in all versions of Windows. You have to enable kernel debugging. It is not something you want on normally. So now I've turned it on, and I think I do have to restart after doing that. See, this, I used to use a product called LiveKD, which is a Windows internals product, but now it's all built into the debugger, which is very nice. Yep, all right, so you run WinDbg Preview and then attach to kernel. So WinDbg Preview, right click, run as administrator. Okay, file, attach to kernel, and now you hit the local tab, and OK, and it will attach to the local kernel on a local machine. If you have done any kernel debugging before, you may be aware that this is impossible. You can't debug the kernel you're running on because you couldn't put a breakpoint in it without stopping the machine you're using. So what this is doing is it's letting us have read-only access into the kernel, which is what the LiveKD product did. So we can now examine the kernel. We cannot actually modify it or stop it, but we can examine it to see how it works. So you can execute commands here like lm for loaded modules, and it'll give you a list of loaded modules. And notice this one, NT, with a long path here, that is the kernel, NTOS kernel. And that is the heart of the operating system. It's the part that runs with full privileges, the part that can directly access hardware, and for short, they call it NT to make our life easier. So we can click, it's a little bit more graphical than the previous version. You can click NT, and it shows you some information about it, like how big it is and such. It's really not very big. And you have links like functions. So I can hit functions to see all the functions in the kernel, but there are tons of them, and so now if I scroll back up, I can use an alphabetical list to make a list that is ridiculously long for each letter. So this is not very useful. You know, the GUI is pretty lame. That's why, even though they've added some of these blue links, you mostly have to use the command line anyway to get things done. However, there's also local help. In the ribbon on the right, I should see local help, and I do, OK. And that gives you the same chum file that we've been seeing for years, but it's a little bit prettier looking. This is where all the real information about how to use WinDbg always has been. You can totally learn how to use it from this help menu. They made it a little easier to find. So now we can disassemble a function. UF will unassemble a function. You can see the kernel. So I do this. This is nt create file, and that is the assembly code. That is the whole function there. Let me shrink this down. It's not very big, as you can see, because all it does is call this other thing nt IOP create file. But anyway, it prepares it and does it. So that's the raw hex bytes. You can now search memory for things. If I want to find this pattern, it's going to find it once, that pattern 442440, which is this $at. And you can find strings. You'll see this will find all ASCII strings of length 3 or more, and so on. You can hunt through the kernel and find things. And you can examine the contents of memory, like DB, NT. This will give you a dump of it, like Wireshark. It gives you the address. Notice this is a 64-bit machine, so I have 64-bit addresses. This is the raw addresses, and here's the ASCII. And this is the kernel itself, NT. I've examined DB NT, so it's display both forms of NT, the both forms being hex and ASCII. And as you can see, it's the same as every Windows executable file. It always starts with MZ, then it always has this program cannot be run in DOS mode, and down later it'll have the rest of it. You can also examine data structures, like this file object. And this will show you what a file is. And so it gives you the data structure of file objects, which has various things in here. The name of the file, here's the file name, a Unicode string, and many other things about a file. So you can see the structure of a file and the devices and so on. You can view processes with TList. And all this stuff is in that help file. So here's the running processes, just like you'd see them in Task Manager. And you can get more information about a process with this syntax, bang process 00, and then the name of a process. And it will tell me more about that process, the image, the process environment block, the parent process ID. And you can get more information about the process environment block by clicking here. And then it will give you more information about it, including the DILs that were loaded and so on. Quite a lot of information. All right. And here you can see the device node for a physical device object. And so PDO is there. And if you click that, it will show you what kind of disk you're using. This is the path, VMware product. If I click the PDO, it will tell me more about it, information about the disk I'm using. All right. All right, and so that's basic view-only debugging, where you view a kernel without modifying it. And you can do real kernel debugging if you have 2 Windows machines. You can use 2 Windows 10 machines or 2 Flare VMs or anything like that. And that's what goes on in this project here, kernel debugging with breakpoints. You need 2 Windows 10 machines. By the way, you can do it all in Azure easily enough. And Azure gives some free service. You can also pay for Azure. You can open these machines, Windows 10 machines in Azure, and you can connect them across in Azure with network connections. Or you can do it locally with 2 virtual machines. And then you just use the settings inside here. You go to net, and you tell it a key for security, like flapjack, dog, frog. It looks like an IP address, but you can have letters in between the dots. That's like a password. And then you give it the IP address and port number of the other machine that's listening. And when you set it up to do debugging, you specify the IP address of the machine that's going to control it and the port number to listen on. So you set this machine to be remote controlled by the other machine. and run WinDbg on the other machine and tell it to control this machine. And now you can actually modify the kernel and put breakpoints in it. So from one Windows 10 machine, you control the other, stop it, and you can have a break into it to see what it's doing. You can modify things, view the loaded modules, and so on. So it's a lot of good, clean fun. All right. That's what I wanted to show you for that one.